All right, today we're going to move away from operations with polynomials. That's what we finished last week on Friday. We finished with divisions. You had a chance to learn synthetic division, which we're going to use again tomorrow. But for today, I need to make sure you understand how to factor by grouping. I'm hoping that everyone here will be strong with this, because if you remember how we did factoring quadratics, all right, we did that by grouping. All right, by expanding that middle term when a was not 1. So I'm hoping that work we did in November is going to make today a little bit easier for you, okay? So let's look at example 1, all right? When you look at example 1, you should see that this is a cubic polynomial with 4 terms, all right? A cubic polynomial with 4 terms. Now, you don't have to rewrite this. I'm going to. Because when I try to factor this, the first thing I notice is that they all do not have something in common. All right? If you look at all of the terms, they have nothing in common besides the number 1, which is not going to help us factor. Okay? Sometimes when you look at these, you'll notice they'll all have a variable, but this 25 at the end does not have a variable. So the only way to try to factor this is by grouping them. All right? So I'm going to group the first 2 together and the second 2 together. Now, when you look at these first 2, x cubed minus x squared, what do these 2 terms have in common? X squared. All right? One thing to remember from our work back in November is you can always factor out up to the lowest number. All right? So they do not have x cubed in common. They have x squared. When you take that out, right? When you take out x squared from x cubed, what is remaining? Just an x to the first power, right? Because remember, if you mentally check this, x times x squared should give you x cubed. All right, you can always do that work in your head. Okay? What about minus x squared divided by x squared? Minus 1. Very good. Okay, let's do the same process, but for the next 2 terms. All right? Keep in mind, you notice, where did I put that minus symbol? I put it in the second group. So always capture that symbol for the third term in the second grouping. Okay? So what do negative 25x and 25 have in common? Very good. So I'm not just going to take out 25. Because that sign is a negative, I'm going to take out minus 25. All right. If you don't do that, if you just took out positive 25, you would notice at the end that this factor here, x minus 1, and my other one inside the parentheses are not going to be the same. All right, which means you can't continue. That must be the same. Okay, so if I divide negative 25x divided by negative 25, what is left? Positive x. You can always check to see if you agree. And then what about 25 divided by negative 25? Minus 1, and always checking to see that what's in the parentheses is the same. All right, if that doesn't happen, then either you've made a mistake or you cannot factor by grouping. Questions, Zach? Okay. Everybody good so far? Now, I'm hoping that the work we did last semester is going to help this process. What do I write for the next step? How do I keep going with this problem? X squared minus 25 becomes a factor. Right, I take the stuff that's on the outside, and what's going to be my other factor? X minus 1, and you only write it 1 time. Okay, now, when we did this last semester, we were done. Okay, but you have to check, are we finished factoring? So Daniel knows, he's been in this class long enough to realize, if I'm asking, we're probably not done. Does anyone see why we're not done? That's not what I was asking. Well, this one, if I were to distribute this out, Zach, I would get the original. All right. It's okay that they're not the same now, right? This is where I need them to be the same. So I brought down one of them. But do you guys see the x squared minus 25? Does anyone? Yes, it can be factored. You know what this is called? X squared minus 25? It's called dots. It's the difference of 2 squares. All right, guys, that's never going away. All right? Even in college, if you take an algebra course or pre-calculus course in college, it's going to be there. Bless you. All right? So at some point, you'll be done with dots, but not today. Okay? Now, when you do that, you look at the x squared. What's the square root of x squared? Just x. What's the square root of 25? 5. So you're going to write x minus 5 times x plus 5 times x minus 1. Now, we are finished. I know. Okay, so, Josie, right? You know I don't deal in absolutes. I know many of your brains want to deal like, it's always going to happen that way, right? What if it had said, Josie, x squared plus 25? Is that the difference of two squares? No, that's the sum of two squares. And SOTS is not a thing. Okay? The sum of two squares is not a thing. So if you see addition, that doesn't mean you get to keep going, right? If this had been x squared plus 25, I'd be finished. I'd be done the step before the end. Okay? All right, now, one more thing before I want to officially finish this micro lecture. I want your brain to understand, I try this every year, I want your brain to understand that the very beginning, this cubic polynomial with 4 terms, and the very end, x minus 5 times x plus 5 times x minus 1, are the same thing. They're the same thing. This here at the end and this here at the beginning are the same thing. One is factored, all right, root form, if you will, and this one is standard form. Okay, but they're the same. All right, your brain needs to know that for the